Hey there. Most of the programs we write at first, they just talk at us, right? They run, they print a few things, and then they're done. But what if we could actually teach them how to listen? Well, today, that's exactly what we're going to do. We're going to turn your Python programs from a monologue into a real conversation.
So let's kick things off by looking at what it means to go from static to interactive. We're going to explore the real difference between a program that just blindly follows a script and one that can actually react to you.
So think about it. Is your program just talking to itself? A program that's hard-coded to greet one specific person is, well, it's not very useful, is it? Let's see exactly how we can smash that limitation.
And wow, this slide just lays it all out, doesn't it? On the left, in that static program, the line name equals Alex is completely locked in. That program will only ever greet Alex. But check out the code on the right. That one line, name equals input, enter your name, it changes the entire game. It tells the program, hey, pause for a second, ask the user for their name, and then use whatever name you get. Suddenly, it can greet anyone.
All right, so it's time to officially meet the tool that makes all of this possible. This one simple built-in function is the absolute key to unlocking truly interactive programs in Python.
The input function basically has this really simple three-step job. First off, it shows a message to the user. We call that a prompt. Step 2, and this is the cool part, it completely pauses your program and just waits. It waits for you to type something and hit that enter key. And finally, step 3, it grabs whatever you typed and hands it back to your program as a little piece of data you can use.
Okay, let's break down this little two-line piece of magic. The first line uses input to show the message enter your name on the screen, and then it waits. Whatever the user types in gets saved into that variable we called name. Then, the second line just prints out a friendly greeting using whatever's in that name variable.
So what does this actually look like when you run the program? Well, this is what you'd see. That first line of code runs, it prints our prompt, and then you get this blinking cursor. Your program is now waiting, it's listening. And in this case, the user, Alex, types in their name and hits enter. And boom! The second that user hits enter, the program snags the text Alex, and the second line of code finally runs, printing out our personalized message, hello, Alex. And just like that, you've had your first real conversation with your program. How cool is that?
Okay, so we've seen how awesome input is, but now we got to talk about its one single super important rule. Getting this wrong is a classic stumbling block for new programmers, but once you get this, you'll be golden.
And this is it, right here. It does not matter what the user types in. It could be their name, the number 42, the price of a car. The input function sees all of it as just text. It gives it back to your program as something called a string, which is just the programmer word for a piece of text. For the input function, numbers don't exist. There is only text. So that brings up a really interesting question, doesn't it? If input only ever gives us text, what on earth happens when we ask the user for a number, like their age, and then we try to do math with it? Let's try a little experiment with the code you see here. Now, this looks totally fine, right? It seems so logical. We ask for an age, we get it, and then we try to add 1 to it. But you have to remember the all-text rule. If the user types in 15, that age variable isn't holding the number 15, it's holding the text 15. And bam, that's where it all falls apart. Your program is going to crash with an error. And why? Because you're asking Python to do something that's literally impossible. Add the number 1 to the piece of text 15. It's like trying to add 1 to the word hello. It just doesn't compute for the computer.
So what's the fix? Well, we need a translator. We need a way to tell Python, hey, listen, I know this looks like a piece of text to you, but I need you to treat it like a number. So let's meet the tools that get that job done.
And this slide just nails why we need that translator. On the left, when you try to add the text 15 to the text 1, Python just smushes them together to get 151. That's something called concatenation. But what we want is what's on the right, real, actual math, where the number 15 plus the number 1 gives us 16. So say hello to our translators, int and float. These are also built-in Python functions. Int, which is short for integer, takes a piece of text that looks like a whole number and officially converts it. And float does the exact same thing, but for numbers that might have a decimal point in them, like prices or measurements. So let's go back and fix our broken code, and we'll do it in 2 clear steps so you can see exactly what's happening. First, that age_text variable gets the user's input as text, just like before. But now, look at that second line. That's our translation step. We use int to convert that text into a real number, which we store in age_number. And now that final print statement works perfectly. Now, we can actually make this a lot cleaner by combining those 2 steps. And this is how you'll probably see it done most of the time. Look at that first line. Python works from the inside out. So first, it runs the input function and gets the text from the user. Then it immediately hands that text directly to the int function to be converted, all in one go. You get the same result just in one clean, readable line of code.
So whenever you need a number from a user, just remember this simple little recipe. 3 steps. Step 1, use input to grab whatever they type. Step 2, immediately wrap that input function inside of int or float to do the translation. And step 3, you're good to go. Use your new number variable in any math you want.
Okay, enough talk. You've learned how to make your program listen, and you've learned how to translate what it hears. Let's put these new skills to the test with a quick challenge.
So think about this for a second. To calculate the area of a rectangle, you need 2 things from the user, right? The length and the width. And both of those could totally have decimals. So how would you write a program that could handle that?
And here's how you do it. Let's break it down. You can see we're using float this time just in case the length or width isn't a whole number. The first line asks for the length and converts it. The second line does the exact same thing for the width. Then the third line is just simple math. Multiply them together. And finally, we print the result. See? This pulls together everything we've just learned.
All right, so let's wrap this up and really lock in the most important things you need to remember. First, always use input to get information from your user. Second, never forget its one big rule. It always gives you back a string, a piece of text. To do any math, you absolutely must translate that string using int for whole numbers or float for numbers with decimals. And when you combine these tools, that's when your programs truly become interactive.
So I'll leave you with this question. You've just given your program a voice and ears. You've opened up this entire world of possibilities, from building simple calculators to maybe even complex choose-your-own-adventure stories. The only question left is, what are you going to build first?